Hi, pre-calc honors. Sorry to give you homework right after a quiz, but life stuff. I want to talk about identities. I want to talk about various little connections between all the trig ratios. And this is going to help with tonight's fairly short worksheet and a little bit help for the rest of the packet that we're going to start. So first I want to talk about something that we've talked about before, and that is squaring a ratio. If I say cosine of 30, all right, I'm pretty confident that you all know we're in quadrant 1, we have a reference angle of 30, and we can build the triangle darn fast. Short leg, hypotenuse, long leg. You need to be that fast. Cosine we know is x over r. There's our ratio. Now, sometimes we wish to square that ratio. So if I wish to square cosine of 30, if I want to square the ratio, I want to be careful. I don't want to put the 2 there because it almost implies that I'm going to square the angle and find the cosine of 900, which is not what I want. I want to square the actual ratio. So we would square root 3 over 2, and we get 3 over 4. And we talked about this briefly in class, but I want to really hit it hard now. When we want to square a ratio, writing with parentheses is awkward. So we've determined that we can write it this way. All right, this looks a little weird at first because it looks like you're squaring just like the word cosine, but that really means that you're squaring the ratio that comes out of it. It's just shorthand. All right, so now what I want to do is I want to explore relationships between some of these ratios. So first, I'm going to pair off the sine ratio and the cosine ratio. I'm just going to pair them off. I'm going to pair off the secant and tangent ratios, and I'm going to pair off cotangent and cosecant. Now you might be thinking, well, why those? What is the purpose in pairing off these ratios? Well, the sine ratio is y over r, cosine x over r. Secant is r over x, tan is y over x. Cotangent is x over y, cosecant is r over y. If you notice, the pairings, they all have the same denominator. So if I want to add or subtract sine and cosine together, I have a common denominator already there. It's easy to add or subtract, easy to add or subtract. You may have even noticed this when we used some of our identities before with the sum and difference. Now, instead of just adding or subtracting sine and cosine, which doesn't do much, what if I want to square sine and square cosine? All right, so obviously I'm squaring the ratio, so that becomes y squared over r squared. This becomes x squared over r squared. Now, if I want to add or subtract those, that's great because I can. I have a common denominator. So if I add them together, just because I want to, I can shove these together. And if you think about it, what is y squared plus x squared? Doesn't that equal r squared? So by adding the sine squared ratio and the cosine squared ratio, I ended up getting 1. So this is known as a Pythagorean identity. There are 3 of them. This is the most important one I think you could learn, and that basically says that if you have the sine squared of an angle and the cosine squared of an angle and you add them, you'll always get 1. I'd like you to write that down. I'd like you to have that one memorized. Now, I believe we can do something with secant and tangent as well because they have matching denoms. Okay? So I'm going to square the secant. I'm going to square the tangent. Now, secant turns into r squared over x squared. Tangent, when I square it, is y squared over x squared. All right, common denominator is great, but if I add these, be careful because adding them is not going to yield anything good. If I add r squared and y squared on the top, it doesn't mean anything. But r squared equals x squared plus y squared, so what if I had another x squared over here? And this would be true. So the x squared plus y squared equals the r squared, and this is just a fancy way to say 1. So secant squared is equal to tangent squared plus 1. That is another Pythagorean identity. Oops, that's an equal sign. Okay, that one, it might be nice to memorize, but I'm not going to require it yet. There's also going to be a Pythagorean identity coming out of this one. I'd like you to explore that on your own on the sheet that I gave you and see if you can come up with that. That's basically number 1. Come up with an identity relating these. Is it cotangent squared plus cosecant squared equals 1, or some variation of that? Now, just so you know, these Pythagorean identities can be written a little bit differently. For example, if I take this identity and subtract cosine squared from both sides, I get sine squared equals 1 minus cosine squared theta. So if I ever see a sine squared theta, I can replace it with 1 minus cosine squared. Obviously, I can do the same thing with cosine squared. If I want to get cosine squared alone, I can subtract sine squared. So there's variations to these identities. You don't need to memorize all the different permutations, but they exist. Now, I have heard a rumor that every function out there, every trig ratio out there, can be written in terms of sine and cosine. Well, first, let's list the 6 ratios. Sine, cosine, then we have the cosecant and secant, and then we have tangent and cotangent. And the rumor is that all of these can actually be written in terms of sine and cosine. Well, this is easy because they're already written in terms of sine and cosine. Cosecant, isn't it the reciprocal of sine? So can't we just write cosecant as 1 over sine? Isn't secant the reciprocal of cosine? So we can write that as 1 over cosine. So those aren't real shocks. But what about the others? What about like tangent and cotangent? Can they be written that way? Well, let's look at something here. I want you to pretend that I have, hold on one second.